Alright, so taking a look at our Unit 6 review here. First two questions is the basics of slope, so knowing our vocab here. If we're up from left to right, it's positive. Down from left to right would be negative. Looking over here at question 2, so this question deals with those kind of unique slopes. So if we have a vertical line such that it's x equals some number, that's an undefined slope. If we had a horizontal line, that would be y equals some number, then the slope would be 0. Moving on down here, so graphing our equations, the key idea here is that we are in slope-intercept form. So it's y is equal to mx plus b. Really awkward timing with the bell, but we're going to power through. So since we're already in the form y is equal to mx plus b, we need to identify our y-intercept, our b of 4, because it's plus 4. And our slope there, m, is negative 3 over 2. So if I'm looking through my answer choices here, a is not going to work because that's the y-intercept of negative 4. Neither will b. Neither will C. Now, this one happens to be where we can just look at that y-intercept and see our choice is D. But again, let's just do our check here. So we're at positive 4, and then the slope of negative 3 over 2 means I'm going down 3, right 2. Now, we see the units on here are by 2, so that means halfway between represents 1. So if I go down 1, 2, 3, right, 1, 2, we can see we have our nice slope there, so it matches up. Looking at question 4. So to graph, we want to get the slope-intercept first, so that means I need to move my x term over. So I'd subtract 3x from both sides, giving me 2y is equal to negative 3x plus 6. Now, in order to get just y, I'm going to divide every single term by 2. So I get y is equal to negative 3 over 2, because that does not reduce, x, and 6 divided by 2 just gives me a positive 3. So if we look through here, again, we can eliminate just by looking at the y-intercept here that a, b, and c won't work. But again, we always want to check to make sure. So I'm at a y-intercept of 3, then down 1, 2, 3 over 1, 2. We're good to go for choice D. Alright, looking at 5. So we need to get just y. So if I divide both sides by 3, I'll get y is equal to negative 5. So this is a horizontal line. Again, if we had x is equal to some number, it would be vertical. But in this case, we have a horizontal line. So if we check here, we'll get choice A. You can see choice B is similar, but that was through positive 5. Number 6. So again, let's go ahead and get everything set up first with just y. So I'm going to divide everything by negative 2. That would give me y is equal to negative 18. Negative and negative make a positive 6x. Now, we know that order doesn't matter, but let's go ahead and just change our order around so we get that nice slope-intercept form of y is equal to mx plus b. So I have a y-intercept of negative 18. If I'm looking through here, well, a might hit at negative 18, so we're going to say that's a maybe. B, that's definitely not at 18. C, definitely not at negative 18. D, if I'm looking where this line's going, there's no way it's going to hit at negative 18. This one's going to hit up here at positive 18. So that maybe we said for choice A, that's going to be our best bet there for the correct answer. We could also check the slope as well to make sure it matches up with that 6. Okay, graphing the inequality. So we're already in slope-intercept form here. So we're looking for a y-intercept of negative 3. And then whether we use a test point or whether we remember that, again, if it's the y by itself, this would mean below. Again, test point below either way. Look at your notes for that. So let's see. We need a y-intercept of negative 3. So A is a possibility. B is not going to work. C is not going to work because we want that negative 3 for a y-intercept. And then D is not going to work. So again, you can see that we're negative 3 for our y-intercept. Our slope, negative 1/2, means I'm going down 1, right 2. And then the below shading, so choice A. Again, my best method for these, I would suggest just graphing them aside the way we're comfortable with, and then looking at the graph that matches up. Here, the key is that we have to divide both sides by that negative 1 in order to get just y. And then remember, with inequalities, when we divide by a negative, the sign switches. So I'm looking for a y-intercept of positive 1. So let's see. Looks like our choices, well, A doesn't work. That doesn't look like it's going through 1. So we can get rid of that one. And now, let's see, okay. So we want a slope of negative 5. So I want to go down from left to right. So B is definitely not going to work. Nor is D. So our choice is C. And again, we could check that just by using some test points in the shading below, right? So the less. And again, we could just go ahead and plug one in there. So we get a false over here, if I plugged in, say, like 4, 2, that'd come up as false. Or if I plugged in something over here, it'd come up as true. Alright, going through here. So here we're just finding slope. So I already wrote out the formula again. That will not be something that I write on the board. You have to have that memorized by this point. So here, if I plug in my y1, I'd have negative 14 minus 6. And then x1 is negative 7 minus 5. So I'd get negative 20 over negative 12. Well, negative divided by negative is a positive. And then if I reduce this, they're both divisible by 2. And then they're divisible by 2 again. So we should end up with 5 over 3. So whether you do that by hand or with technology, you need to make sure that you can execute that properly. Oh, my bad. It's also 4, not 5. No, it is 5. My bad. Sorry, guys. It should be end up with 5 over 3. Okay. Over here, again, we already have it in slope-intercept form, so we're given the graph. If I'm looking here, I can see my y-intercept is here at negative 1. So I can get rid of choice D. And then I have a positive slope, because I'm going up from left to right, so I can eliminate C. And if I'm counting to get to it, say I go up 1, 2, 3, and right 1. So my M here is 3 over 1, which is just 3. So our choice would be B. Okay, 11 and 12, so we're given some information here. We need to get to, this one just wants us to get the slope-intercept form. So I plug in my y, my m, and my x plus b. Multiplying on the right side first, just as we have before, I'll get negative 6. And when I add over, I'll get 1 is equal to b. So nicely here, again, if I wanted to write the whole thing, I could go ahead and say negative 3 over 2x plus 1. But we can see pretty quickly our choice here is D. Alright, when we're given this, we got to get to standard form. So first thing I have to do is find the slope. So here I'd have my y1 minus y2. And then x1 minus x2, so I'd get negative 15 over 3, which reduces to negative 5. Again, always check whether using GeoGebra, calculator, or in your head that we're reducing those fractions as much as possible. So then I need to find b. Alright, so if I start here, y is equal to mx plus b. I'm just going to use this first point. Again, it doesn't matter which one we use, so I'd have negative 13 equal to my m times my x plus b. Negative 13 is equal to negative 15 plus b. I'd add that over, and I'd find that b is equal to 2. So now my equation looks like y is equal to, our slope was negative 5x, and our b is 2. To get to standard form, I just need to get the x and y on the same side and eliminate all fractions. So here I'd add 5x to both sides. It's giving me 5x plus y is equal to 2, which, conveniently, is our answer. Going on to 13a and b, so we're finding the slope. So I've got negative 5 minus 1, negative 2 minus 1. That would be negative 6 over negative 3, which reduces to a positive 2. And in here, describing it, it's positive. For this one, again, we can pick any 2 points. So I'm just going to use the first 2. So I'm going to call this like my x1, y1, x2, y2. It doesn't matter which one you pick, or the order as long as they're together. So, my y1 minus y2 would be 2 minus 2 over negative 6 minus negative 2. So on the top, 2 minus 2 is 0. On the bottom, negative 6 minus negative 2 would be negative 4. Now, this is something we have to remember. When we have 0 on the top of a fraction, 0 divided by anything is 0. If this were reversed, if I had something like some number over 0, this would be undefined. So again, make sure we're able to differentiate between those two. Okay, let's see where we're at here. Alright, coming to the end here. Okay, I know this video is going quick. Again, we've kind of done a bunch of these, so again, reference those notes and ask questions if you got them. Okay, we're going to slope-intercept form here. So first we need our slope from these 2 points. So I'm going to go back to negative 7 minus 5. Over 4 minus negative 2. That gives me negative 12 over 6, which is equal to just negative 2. Now I'm going to plug into that y equals mx plus b. I'm just going to use this one. And again, it doesn't matter which one we use. So that's my slope. And then my other point happens to also be negative 2. So I have 5 is equal to 4 plus b. subtracting 4 from both sides, I'd get 1 is equal to b. Now, we have that. So I have my m is negative 2, my b is 1. So our slope-intercept form is y is equal to n of x, and then our b is a positive, so plus 1. Here we're given a graph. We need to write the slope-intercept, so I'm looking for my b here. It's 2. If I'm looking here, this looks like another good point to use, right? It's on those nice grid lines. So my slope here, I'm going from left to right, just like all the other times. So I go up, it's positive 1. And I go right, 1, 2, 3, so it's 1 over 3. So my equation is y is equal to 1/3 x plus 2. Okay, so we want to get to slope-intercept form first here. So I'm going to need to move my x over. So I'd subtract it, which would give me negative 5x, or negative 5y is equal to negative 15x plus 20, dividing both sides now by negative 5 to get just y so I can graph. So I'd get y is equal to negative 15 divided by negative 5 gives us a positive 3x. 20 divided by negative 5 gives me a negative 4. So my slope here is 3. We can think of it as 3 over 1. And my b is negative 4. So plotting, I'm going to go up 1, 2, 3, right 1. And we've got our graph. Here again, we want to make sure we get y by itself. So I'm going to subtract 9 from both sides first. So I'd get negative 3y is equal to 2x minus 9. Dividing everything by negative 3 would give me y is equal to negative 2/3 x. Then negative 9 divided by negative 3 would be positive 3. So I have my m and my b. So we're at 3. So I'm going to go down 1, 2, right 1, 2, 3. And we are good to go there. Alright, last two questions for our review here. Let's do 20 first. So, greater than 2. So since I don't have a line underneath, I can know that that's just going to be a dashed line, whereas if it had the or equals to clause on the bottom, then it would be a solid line, because that means that number is included in our solution set. My suggestion with things like this, so if I have x is less than, x is greater than, say some number, or if it's y, right? Either way, read it out loud. That's the easiest way to figure these out. So in this case, the problem we're actually doing, we have y is greater than 2. So if I think about that y-axis, well, here's 2 and I want greater, so I know I'm going to shade the top. Those ones sometimes trip people up, but again, if you just read it out loud with the less than versus greater than, it'll kind of intuitively help us out. Okay, last one. This is the shortest review video I've made. I'm pretty impressed right now. Alright. Are the points below solutions to the inequality? So what we're doing is just plugging in essentially our x and our y. So for the first one here, I have negative 5 greater than or equal to 3 times negative 5 plus 1. So I have all numbers on the right side, so when I simplify, well, 3 times negative 5 is negative 15 plus 1 gives me negative 14. I'm just going to do the work for the bottom one here as well. I have negative 4 greater than or equal to 3 times 0 plus 1. Negative 4 is greater than or equal to, if we do this, we got 1. So on the top here, I'm looking at this statement. Negative 5 is greater than or equal to negative 14. If you rapidly know that answer, great. If not, talk with me today in class. Draw out a number line. Anything to the right on the number line is greater. In this case, you should get an answer of true. So since the answer is true, this is a true statement. Yes, it's a solution. Down here, I got negative 4 is greater than or equal to 1. That's not the case. So since this is false, our answer is no. It's not a solution. At this point, we have done so many of these in class, right? Look back at that practice, make sure you're prepared. And again, once you've completed this review, make sure you check it with all the different answers we've discussed on here. If you have questions, ask them. And let's see if we can all do really well on this exam, just like we did on the last one.